presentation by Gianfranco. And Gianfranco is an associate professor at the University of Stavanger, and he is also leading the Computer Networks Research Group at the university, and he is the principal investigator for 5G Modanel, which is a research project funded by the Norwegian Research Council that looks at the dependability and security in 5G multi-access edge computing. So I think we should just go directly over to you, Gianfranco.
Thank you, Anders. Thank you for the presentation and invitation. So this is the outline of my presentation. I will briefly introduce 5G, or the concept that everyone can understand it in 5G. I will go a little bit more in detail introducing the edge computing, the different solutions, and then I will present a little bit the challenges that there is in this 5G edge computing technology. And then, as Anders say, I will present even briefly, even a little bit my project that is connected to the topic. So many of you heard about 5G and is familiar with the 4G because we have now in our desk, in our pocket, the 4G. So, but with this generation, we mean generation of mobile networks, okay? And along the last decade, there have been a lot of evolutions. So in this crowded picture, I won't present this evolution, and but I want to focus, of course, in the 5G. I will not present any technological details. So first, we had the first generation that is actually not included. It was analogical. We had an evolution. It became digital with the second generation and the GSM. Then we have a technological evolution from circuit switching to packet switching that practically means from the old version of telecommunication in an old style to something that is more similar in generation. And then in this, so from just service that were related to voice, we went more on managing data. And the critical part that everyone knows about the mobile network that everyone wants more was the data rate, okay, or sometimes called bandwidth throughput. So we wanted the megabit per second or even gigabit right now per second. There are many, okay. So from the first services that we had in 3G, we went to the mobile broadband communication with 4G or LTE. And then this was in beginning of 2010. And then it started even more evolution. So with LTE Advanced, LTE Pro, so it increased this bandwidth. But with 5G, and that is the main things that you need to understand, that we have, yes, an enhanced broadband. Okay, so what we can see here, but we have even different use scenarios, okay, that before they were not considered. Now there is this that is called massive machine type communication, but there is another even use case that is called ultra reliable latency communication. Okay, let's see a little bit more in detail what are these use scenario and what they are used for. Okay, so what we have that if here, as we say, we are able to have services that are able to transfer gigabytes in a second, and close to here we have kind of services like the ultra high definition screens, okay, this kind of television. Then we have something here that you see is really related to this seminar. We have services that are on smart cities, okay. And here, because with this massive machine time communication, actually we are it's a kind of another way of talking about Internet of Things, okay. So how we can connect sensor and retrieve data they are massive because we have thousands of these devices. And then something that it looks like not related or is not expressly said smart cities, but still is related to the smart cities, even this URL-C, ultra reliable and low latency communication. And this because we have even things like self-driving cars and mission critical application that can be related to what we do, and something that is the industry automation that is still it's kind of related. Okay, let's see. This we are going a little bit more technical. Let's see what this doesn't mean in actually the kind of metrics that are important for each of these communication. If you see the one that was announced mobile broadband is the data rate. Okay, we want these megabits. But in the other service, this metric is not important anymore. So it's something that is completely different to what it was expected to a normal mobile network. So we have this massive machine type communication. So IoT that we want connection density. That means I want to attach to my access network. I want to attach a lot of devices, thousands, even millions of devices. And then we have something that is requiring actually a lot of a really low latency. Okay, here we are talking about numbers of 1 millisecond. So it's dramatically low. If we talk that previous generation, they were really going maximum to 10 milliseconds, but really maximum. So it's not actually things that are a human being can notice. They are in the order of around 100 milliseconds. So it's really low latency. Okay, and one thing that needs to be noticed that if okay, this one is an evolution of the classical cellular communication, cellular network. This one is IoT, and maybe there are technology that were not the classical technology. Maybe some of you heard about narrowband IoT, or you heard about LoRaWAN, or EEM, that is kind of pushing all this technology inside the regular generation of a cellular network. But the part that is really new is this one about the URLLC, okay, ultra reliable low latency communication. And since we want to see this low latency, the edge computing is something that is able us to achieve this one. Okay, so if we need usually do some computations that we want to use our smartphone, usually what we are doing, we are using a cloud. Okay, a cloud that unfortunately is far away to the end user device, you know, so it's far from the smartphone. So one of the solution that has been developed during the last years is actually the edge. Okay, so moving the cloud in a smaller version close to the access network. Okay, so here, for example, we have our base station, and they are next to the this base station. This, as I said, our target is reducing the latency. But actually, you have even other advantages like having a contextual information. So since it's close, I can have information about the context next to the smartphone in a real-time way, so really fast. But it can be used as a cloud offloading. So instead of making the cloud really busy, I can do some computation just in the edge, and that is helping us even reduction of the traffic congestion. So here it means that you have traffic that is going from the edge, from the access network, from the base station to the cloud. Instead, this traffic will be completely reduced. Okay, so this is the idea. Okay, but what has been implemented? Okay. First idea was is called Cloudlet. It's being developed by the Carnegie Mellon University. Was in 2009, and the idea was just using these microcloud that are really close to the mobile user. So if you see here, it's a really crowded picture, but there was just, okay, maybe we can use a cloudlet in the coffee shop, okay, instead of going to the distant cloud on internet. So that was the first idea. The second idea was is called fog computing, and was firstly introduced by Cisco in 2011. And then from 2015, has been started and is managed by this Open Fog Consortium. The idea here is getting a little bit more evolved. In here we have mainly the concept of 3 layers. So we have a bottom layer that are the IoT devices, okay, the Internet of Things devices. Then we have an intermediate level that is the fog devices, and then we have a top layer that is the cloud devices. And here we have an interaction between the different layer, and is about for managing these IoT devices and providing advanced services. Another solution, and it's the one that I will describe a little bit more in detail, and I will use as a reference, is called multi-access edge computing. And this is has been under definition by the ETSI, European Telecommunication Standards Institutions. And before, actually, until 2017, was called mobile edge computing. Now it's called multi-access computing because it's including not only mobile networks like 4G, 5G, but also other access technologies like the Wi-Fi or even fixed networks. Okay. Here there is the architecture. Of course, I don't want you to see here. What I want you to notice is that here we have multiple hosts that are these devices, not these micro clouds. And then we have some management that is at the host level. And then all these host cloud, they are within a system. And that for this one, we need even a system management. Here we have a comparison. Here there is even another technology that but is not considered technology, edge technology like mobile cloud communication. Here is just connecting cloud to the mobile. Okay, so if you see all the numbers, they are completely different. One thing that you need to notice here is that if you see here, the MAC is the one that is more connected to the telecom operator, so it's managed by the telecom operator, and it's the one more connected to the technology in the access network. Okay, so that's why one of the reasons why we are considering. And one thing that if you see the previous architecture is not connected to the cloud. Okay, if you see the fog is always in architecture where the cloud is concluded. Instead, the MAC, the multi-access edge computing, is something that is working, can work even standalone. Let's see here, I'll give you a picture from the ETSI standard about where actually these MAC hosts or this edge computing platform they are placed. And you see we have you have different options. You have the first two options where they are really close or really into the base station or close to the base station. Here you have a third option that is okay. Let's put in this network aggregation point. So it's grouping multiple base stations, or we have even a fourth solution where we are putting to the core network. Okay, so even more far away. Okay, so you have even this flexibility. Okay, the most natural part is close to the base station, but actually the ETSI standard, it doesn't force you to do that. Okay, now we had a little bit of a view about edge computing. Let's go on to see the challenges. The challenges, what I want you to focus in three perspectives. So we have the security, we have the dependability, and we have the performances. We have a little bit delay because of all this pandemic situations. Everything's getting a little bit delayed, but we are even right away within the project that we are doing a survey that is almost ready to be submitted, and is try to consider the 5G MEC using these three different perspectives. So, but what are these three perspectives? I will just present the attributes. Okay, what are usually the name that you see connected to these perspectives? So, in security, usually we talk about confidentiality, integrity, authentication, privacy, and reliability. So, there are terminology that are more or less you more or less heard. For the performance, even here, you have something that you heard, that is throughput, and we are referring something that is the data rate that we saw before. But you have things about latency, okay? So latency, delay. We have jitter, that is just a variation of this of the latency, something that is really relevant nowadays. The performance, they are much better, but before you had you have problem like the buffering of the video, and usually buffering the video is because you have an high jitter, okay? Because the variation of the latency is increasing, so you need to rebuffer the video. And then here there's the terminology that maybe most of you don't know, the dependability, and here is connected to terms like availability, reliability, survivability, safety, maintainability. Okay, so all these terms that are connected to the fact that maybe in a system you can have a failure. Okay, and even all the system can happen as failure, and you want to do something that is this failure, they are getting more and more rare. Okay, so let's get a step forward. Why these three perspectives, they are important for MEC? Okay, and here you have the one, the user scenario, the new one. So it's called, if you remember, it's called the ultra reliability low latency communication. So you have a part that is related to the performance, a part that is related to dependability, reliability, but take care, is not only reliability, but is even one term, maybe was what's called the term, okay? And this because, for example, a component can be not available, or because there is a failure, but unfortunately even because intentionally there has been an attack. Okay, so this is given the 5G MEC is really critical, and these three aspects, they're really important because we need to analyze them even jointly, not one. Not before we were mainly focusing on okay, it was the dependability, some reliability targets, it was latency, maybe not so much, but it was a lot about the data rate. But nowadays, actually, it's when everything needs to be seen together. And just for remind you, the use case scenario is really relevant because there are things like autonomous vehicle, or industry automation, or mission critical applications. Okay, and I say in this use case, I need to consider all these aspects, all these three aspects together. Okay, so we have our triangle picture, and let's see if having these three aspects together is a problem or not. So, for example, we have the security, that is, we have a lot of security as mechanism, but maybe if you go specific about the encryption, when we are doing encryption, what actually doing, we are increasing delay. So you see there is a conflict here. But let's see instead between performance and dependability. The consideration means that we are reducing the number of devices. And this reduction on devices is, for example, used for improving the energy efficiency. But when you're doing this, what you are doing, you are creating what is called the single point of failure. So you are creating something that is the spot where if the failure is coming, all the system is going down. And you see there is a conflict. And even going forward to the relation between dependability and security, even if it looks like similar, here we have the problem, because one way for bringing dependability is instead creating redundancy, okay, having multiple version of the same devices, that if one fail, the other one is working. But when you are doing that, adding redundancy, you can increase the exposure risk. Okay, so if you see in this triangle, we have relationship between these three aspects that are really, really critical. Okay, so we need to take care about the aspect together and see how these aspects and try to address and maximize the aspects is creating conflict, and we need to address them all together jointly. Let's go a little bit to see one of the use cases that is relevant. For example, we have the V2X, that's called vehicle to everything communication. And you see you have communication between a vehicle and an infrastructure, like the traffic lights, or between vehicle and vehicle, or you have between a vehicle and pedestrian. If you see here, the edge cloud or the MEC is seen as a central focus point in these technologies. Okay, so let's see which are actually the specific kind of application or use case in V2X. For example, we have the road safety use. Okay, so avoiding to have car crash, or in autonomous vehicle, they can provide some driver assistant use case, or you can even in Norway it's not something it's so critical, but in a big city it's really, really critical because you have a lot of traffic, so you need to manage in a smart way this traffic. And then you have something that is even now you have in many cars you have your actually small screen in the car, and maybe you want to stream a video, and that is the case of infotainment and so on. Okay, in all these use cases, there are even more criticality that are typical to the MEC, and that is about the mobility. Okay, usually if you are connected to a base station, and for having a reduced delay, you want you to move this application from the MEC associated to the base station to another, and that is getting critical for the delay. And how you can do that? You can have advanced solution. One solution, for example, is the pre-locations. Okay, so we are predicting which is the path of the car between the different cellular network, and say, okay, it's going like this. So in a proactive way, and trying to predict where will be and start this already the mobility. And so this is I try to go over these challenges that are really typical for this technology. So let's start to conclude the presentation. I want to present the project that is related to this topic, that is called 5G modernity. So the name is the name is 5G management orchestration for data and network integration. And here there are information that already under sale. So it's found the research country, and is a 4-year project. It started last year on April, and they've been delayed now with the Norwegian border closure. So we have only one now. This is already here, but fortunately we will have even the other 2 PhD students and 1 postdoc that will join soon. And we have even 2 international partners, like University of Pisa from Italy and the University of Bucharest from Romania. So I will try to just explain you what we are doing in this project. And our main target is actually the 5G multi-access edge computing technology. And what we are doing, we are investigating security and dependability. That doesn't mean that we are not addressing performance, but we keep the performance of something that we need to achieve, and what that is already there, that you want to go on top. We want to add security and dependability. And what we are doing, we will one of the PhD we work on creating models that are actually investigating this security and dependability in 5G MEC. Then we will be another postdoc, one postdoc, another PhD student that is working instead of creating algorithm solutions that are actually improving the dependability and security. And for doing this, we will use classical technique like mathematical programming, but even new technique using artificial intelligence and machine learning. And then, and here is where we have the PhD student is already working. We will create even a vehicular communication testbed, okay, where we are using some smaller remote controlled cars, and we will test if actually the algorithm will develop for orchestrating the resources that are both related to the data, but also to the network, and that's why the name of the project, they need to be orchestrated together, okay, managed together. Okay, so that was all. I hope that I've not been so fast, or but hopefully we will have questions. Anders, we cannot hear you.
Sorry. Thank you, Gianfranco. I hope that at least laid out some of the prospects and also some of the challenges that we're facing to realize like future applications in smart cities. I will go on to. I hope you can ask questions in the Q&A. If you have questions for Gianfranco, please go ahead and write them. I will go directly to Henri Hamier from Telia, and Henri is head of strategy for the product area IT services at Telia. And as you probably know, Telia is one of the mobile network operators in Norway, and I'm very much looking forward to hear what their thoughts are about like the potentials for 5G mobile communication and edge computing technologies from their viewpoint. So please go ahead, Henri.
Thank you. Very happy to do that. Let me share my screen and presentation. I hope you can see it right now. And in presentation mode. Well, first of all, hello from the Telia Helsinki office where I work. It's nice and sunny, getting springtime here, bringing back the forest into our minds probably. And talking about forests and trees, when I listen to my colleagues and many people talk about 5G or edge computing, I sometimes get the feeling that we are so fascinated by the individual trees and their features, be it capacities, latencies, whatnot, that we have a hard time seeing the forest and where the light comes from and how it actually evolves. And that is what I try to outline in my presentation. I will touch upon some of the things that go on right now, what are the key trends that we see, and assess where we are today in the adoption of 5G and edge computing technologies, what we see our customers do. But more importantly, where will we go in the long term? And I wanted to select this picture because I think the long-term view is extremely exciting. We have a number of trends that will come together in the next 3 to 5 years. That typically spells for a paradigm shift, and I'm quite confident that actually the next years will, with the aid of 5G and edge computing technologies, do to our lives what the Internet 2.0 and the 3 and the 4G did to our lives, say, about 15 years ago. But let's start. Again, let's look what sort of trees in the forest we have. When you look at our industrial customers, these are the things that they tend to talk about. A number of words, but the common denominators revolve around digitalization. which is not about technology actually. It's a fundamental change how the companies operate. Often it means a change in the business model. But some of the key components are prevalent. There's the AI and ML. There is analytics in many shapes and forms. There's automation. There's naturally the sustainability and circular economy needs that are very close to our hearts. In connectivity, we see new mobile technologies. I say in plural on purpose. 5G is not the only one. There's other exciting mobile technologies as well. Telia is not engaged in them, but we trust in our 5G. But there's many of them. Some of the fundamental changes we see here is actually naturally the capacity and the sort of technological performance. But from the business model point of view, I think it's very interesting to note that all mobile technologies so far have been sort of best effort type of businesses. And with the 5G will be introduced sort of committed capacity. This is something that is very interesting to many industrial usage cases. And secondly, the mobile networks, as we have known them, are always public networks. Basically, anybody with money can buy a subscription. In future, companies can buy private 5G networks and deploy them at their sites or several campuses and probably connect them. Will that be constructed in physical networks, or in a future years when the 5G protocol matures, digitally, as in network slicing, where we can, if you imagine, slice a network, part of the network that is dedicated to one user or a user group that performs on a national scale as a private network. Again, providing quite interesting prospects. There's changes in the compute, and I think these are probably quite obvious. There's the cloud native paradigm, and I want to underline again the business model. Technology leads always into business model change, and I think this is something that we again sometimes miss when we look at the technological developments. There's everything to do with being data-driven, analytics-driven in the business. And I think again, the platform economy, technological platforms, business platforms, and exponential technologies have actually created completely new industries. And all of these things sort of come together in the compute technology developments. Jumping to where we are today, what do we see our customers doing today? Naturally, we take pride in the interest in the 5G networks and what they do, what they cannot do, when is it available, when do we have handsets, so on and so forth. It's thrilling. From left to right, we see probably most activity today actually in the consumer segment, led by gaming, esports, things like that, that demand extremely high capacity and low latency. A lot of people are enjoying this. On the other hand, we see then industrial sort of proof of concept type of activity, either testing out 5G private networks in various shapes and forms. The same goes for edge computing, artificial intelligence, machine learning, etc., etc. And there's the whole IoT stream of events with sensors and data models and things like that. But anyway, I would say that we are at the beginning of the era. There's still a lot of technological innovation going on. We see relatively little process innovation still going on, some business model innovation, but we're pretty much focused on what is the future technology, how can we apply it, how can we make it work together. Here are some of the examples that we are tinkering with. This is a live customer case, a public one, Konecranes, making these sort of heavy forklifts and things like that. As you can see from the picture, there's cameras, there's streaming servers, there's 5G modems, they are routed, they have a company mobile network leading into the cloud, and we can assist these heavy machines to run autonomously, safely, to the right place, doing the right thing, letting know where they are, etc., etc. And this is probably the future for how major harbors operate. They will be powered by trucks like this, as well as many other heavy pieces of machinery, but all connected, all equipped with sensors, intelligence being either on board or in the cloud or in both. We see augmented reality coming into more and more workplaces. This example is published during the COVID that we hopefully get rid of soon, where augmented reality has tripled in Porsche workshops, probably built on digital twins of the cars that are produced that can actually help the mechanic to spot what is wrong, to set the car right, or the mechanic can be assisted from remote by an expert who can see what the mechanic can see. Again, completely unheard of only a few years ago. This is one concept that we have been developing with a number of heavy industry customers, which seem to present similar challenges on large factory floors or new factory build-outs where you need to do acceptance testing against certain criteria. So to tick the box, does the thing work as it's supposed to work? Or assist maintenance people hunting for faults, why the machinery doesn't work in a very, very complex environment. What we can actually do is that it's hands-free. It's assisted by a private 4G or 5G network, depending on the latency needs. There's a lot of video or voice communication involved. But I think the most important thing is that there's access to information. You can search. You can have operation support. You can see 3D models, digital twins. You can see documents. And with the modern AR glasses, wherever your eye points, it can pop out relevant information to specifically that spot. These are one of the sort of early systematic use cases that we have encountered so far, primarily in the heavy industry. But then again, one could say that these are things that remotely could be made possible only by the incremental development in the networking technologies, as well as in the computing technologies. They are still more or less within the same paradigm that we have seen during the past, say, 3 years, 5 years' time. But what will really make the forest look different in the future? There's a few trends that keep coming up when we look into the future and search. And I think the first one I want to talk about has a funny name, splitting the chip, where today we see devices like mobile phones, laptops, tablets, AR, VR glasses that we talk about all the time as having higher resolution, more computing power, more memory, more processing power, etc., needing a bigger and bigger and more dense battery cooling, etc. The things become quite bulky as the AR, VR glasses on this lady's eyes. On the top left, a video processor that alone requires 800 watts of power. that makes these devices very expensive. They dissipate quite a lot of heat. They are consume a lot of power or have very short battery life. Tomorrow, thanks to 5G and edge computing, we probably start seeing a lot smaller devices, lighter, lower cost, longer battery life, more enjoyable to wear, as in normal looking eyeglasses that will have much more power and features than the big goggles on the left-hand side ever will have. And this is where the 5G and edge computing come together from the sort of economical and industrial use point of view. We can distribute the battery power and therefore the electricity consumption along the continuum from the, let's say, big cloud from the left to the edge cloud, which may be in a mobile operator's base station. It may be a private network at an industrial site, like the harbor truck example showed. It can be at a network node around the cities, and some of it naturally on the device. But it is highly likely that in the future, the devices will be a lot dumber, as it were, but they probably have a lot more sensory technology and projection technologies, but not so much memory and processing power to make the usage of them much more nice. And these two examples here, as you see, are connected to a 5G phone. So wearing them on your eyes becomes a less unpleasant event, as it were. The second then is the Spatial Internet, or the Web 3.0. I have hunted for a proper definition for it for several evenings, but haven't really found one that I would like. But what is often referred to is that it actually brings the internet into a three-dimensional animal, which is the natural way how humans perceive their environment, whereas the Internet 2.0 is always tied into two dimensions. It's always consumed from a phone, a laptop, a computer screen, a tablet, whereas the three-dimensional ever-present Web 3.0 will be consumed via 5G, edge compute, and AR, VR glasses. So wherever we go into a space, we are recognized. The data relevant to that space or whatever we are doing is displayed to your glasses to aid you, to guide you, to make life more enjoyable, more pleasant, or to let other people know where you are, to create a real-time sort of digital twin of what you happen to be doing. And why I'm so excited about the sort of this year, next few years, is that many of these things seem to be coming together. We see the wearable technologies, the interaction layer, where we can use our eyesight and voice, or the sensory information from IoT in an efficient way, rather than being tied to flat screens and two-dimensional information. Then there's the computational layer, which is actually the combination that we are talking about. It's the 5G and edge computing, being ever present, basically always real time, and giving unlimited computing power and intelligence to whatever we do, but in a way that is comfortable for a human being through your eyesight, your voice, your hands, rather than always a device that you need to handle. And then the very pressing question about how to handle the information. We start seeing more and more of the distributed ledger technologies like blockchain, allowing us to gain back the ownership of information pertinent to us and to our lives or whatever we do. And these three layers need to come together. And as it looks like today, that will happen in a relatively near future. There's interesting things going on today, like the Open AR Cloud Association that is actually working on setting boundaries for what the spatial internet will be. And in the upper left-hand corner, you have an illustration of what the world will look like when you walk down the street in a city and view it with your AR glasses. There's a number of things to be sorted out, but a lot of investment, a lot of patent, a lot of new technology, and a lot of new investment is being put into getting these things into place within a few years' time. So what will change? And this is one illustration I saw from a Nokia presentation, actually on the YouTube. There's the networking part, the connectivity. There's the viewing device that needs to become completely different. There's the mapping on information that needs to become from two-dimensional into spatial. And there's the content that needs to be not only consumed when you have a device, but actually wherever you go, let's say being part of your presence wherever you go in every sort of three-dimensional space that you enter, probably first in the cities. So to us, the forest probably will look like an augmented physical industries. There's the augmentation part which helps digitalize physical stuff. And the industries which I think is interesting when we look at the projections where the investments will go to utilize these technologies. On the left-hand side is an illustration that typically we have seen this sort of spearheading investments going into the digital industries. But over the next few years, that will probably turn, and when the technologies mature, we learn how to integrate them. We learn how to scale them. We learn how to make them very safe, and we learn how to operate them like telcos tend to operate their technologies with a 99.999 fault-free rate. We see the investments shifting mainly to physical industries who create these technologies to help them digitalize their operations. With these thoughts, this is how we view the future. There's the interim next few years where we see advances in technology. We learn to apply them, we learn to operate them, we learn to integrate them, we learn to scale them. We learn what the business models palatable to the customers are. And after that, we expect to see a ramp up in the utilization of them and a fundamental change how we view information, how we consume information in coming together of the spatial internet. Thank you.
Thank you, Henri. That was very interesting. And I think actually that leads directly into the next presentation by Ingvar Haugland from Ring Digital, who will talk about a little bit more about some thoughts about how, from industry perspective, how to exploit these new opportunities that the 5G and edge computing provide. Ingvar is the CEO of Ring Digital, which is a company based in Aarhus, and he has a long sorry, he has a long experience from industry and from IT, from the IT sector. So I think I will just go ahead and ask you, Ingvar, to take over.
Thank you, Anders, and both for the invitation and this challenge. Thank you also, Gianfranco and Henry, for interesting and good talks. I was challenged with yet another perspective. How can companies like Ring Digital exploit business possibilities 5G and edge computing represents? And thank you, Anders, for introduction. I will briefly go into a introduction. My name is Ingvar Didrik, and as you said, I have quite some years experience from technology management, background as IT architect, software developer, and today I am combining that technical background with strategy and organizational insight to transform businesses, organizations, and to lead innovative projects. My educational background is a combination of technical, business, and economic, with a master in computer science from University of Stavanger and a master of management from Norwegian University of Science and Technology. And currently, I am the managing partner in Ring Digital, also the VP Technology in Malaysia, a healthcare startup in Stavanger, and the board member in Yago AS. From Ring Digital, we are a consultancy within digitalization, and currently works with the technology side, edge computing. We have used it for years for different industrial projects. A lot of automation and so on ongoing in especially the oil and gas business from before, from Stavanger region, and now even more on other industries as well. Yes, work with different kind of industries, and we are a co-founder of Yago. And Yago, what is it all about? Yago is an arena for business cooperation. It's a knowledge and collaboration cluster that provides a set of autonomous test arenas. And the vision is to be the leading Nordic integrated test arena for autonomous mobility and transport systems. And by integrated, we mean both digitally integrated, seamless user experiences, and not least that we integrate autonomous multimodal mobility across land, air, and sea. Yago was founded last year, end of 2020, and the start was kind of celebrated with a closed kickoff due to COVID-19, quite different from what we had imagined. However, we have gathered some of the more exciting companies working with autonomous mobility, logistics, and inspections in our region, companies that are teaming up with Yago as members of the cluster. And one of the initiatives is to create an autonomous test arena in a vibrant living environment in Forus. And as the map shows, a quite huge area, mostly commercial use and offices today. We have already regulated some parts of this test arena for autonomous mobility and are working towards regulating the whole area as an autonomous test arena, both for vehicles kind of on the ground and drones and so on in the air. At the same time as we are regulating the physical aspect, we are working with the digital aspects of a test arena. And the arena will be open to members of Yago to use for testing purposes, whether it's drone, autonomous vehicles, pods, buses, or for IoT providers. So just a quick introduction to Yago, and And it was founded by Forus Næringspark, Seabrokersgruppen Ring Digital last year, and we have recently partnered up with Avinor, If Insurance, and University of Stavanger, and of course a close collaboration with Nordic Edge, and we are now starting to onboard more and more member companies. And how can we exploit 5G and edge computing in this environment? One of the kind of investments we are looking at are to deploy a mobility hub in the Forus region, right next to the busway passing by Forus. And though several mobility hubs are rising, we see the urge to develop a hub that integrates multimodal transport and not least works as a living lab, an arena to test out vehicles, drones, and other IoT technologies alongside a fully operational mobility hub. And the hub constitutes a vital piece of puzzle for creating a more efficient and seamless mobility experience, connecting the public transport with the first last mile challenge. And the mobility hub is definitely an arena for exploiting 5G edge computing technology. Imagine you as a traveler coming to a new city, a new hub, and can browse your way through the hub to find optimal transport mode through AR technology. Just one use case. Moving forward, we need to calculate the most optimal use of the fleet in real time based on travelers' needs, range of journeys, available resources. It is to create the best user experience. And we are looking into how can we optimize the usage of the fleet moving forward. Today it's a kind of a first come first serve mindset. How can we optimize that moving forward? And 5G edge computing will most likely play an important role for mobility hubs moving forward, with kind of higher volumes of data, real-time data analysis, more IoT devices that can bring better decisions for travelers and logistics. And we are currently working with these ideas to exploit the technology, and there are room for more people to join in, more companies. Another kind of use case, how we can exploit the opportunity of 5G and edge computing is emergencies. And an emergency poses an immediate risk to health, life, property, environment, and so on. Most emergencies require urgent intervention to prevent the worsening of the situation. And imagining how, for instance, real-time video streams and messages to both people nearby, first responders, police, ambulance, firefighters, and so on, may help to get a better situational overview. In threatening situations, such video-assisted operations may become crucial to save lives and secure first responders. Or imagine the usage of combination of insights from video streams and AR technology to guide people away from danger zones. A reliable and low latency network in combination with edge computing may be the key to save lives. Seconds are crucial in such situations. And you need the high bandwidth, you need the high priority to handle large amount of data from nearby sensors, video cams, and so on. Really a use case of the 5G edge computing. So there is already plans for such an emergency exercise in Yago, currently not exploiting the 5G edge computing, but this technology will strengthen the use case in the continuation. As Henry says in his talk, during the next couple of years, we will see a lot more use cases coming alive. And such operations, video assisted on-the-fly analysis to guide people, guide first responders, can make a real difference. That is where we are heading in Yago. So kind of how are we working with this? How are we working with ideation to exploit such opportunities? There are many ways and methodologies that really can help you going. And now I'm talking more into the business side. One of the methods we have experience with is the MIT disciplined entrepreneurship. It's a 24 steps kind of guide to a successful startup. Through the 24 steps, it will help you create a sustainable innovation-based business. And it all starts with kind of understanding the market, understanding the users, and focusing on the value proposition. Focus on the value it brings and the experience it brings to the users. And if you want to keep up with the market pace, because it's really happening fast, as Henry says as well. Things are we're going to see them ahead in the next couple of years. So either for generate ideas for new products and services, or kind of innovating your existing services, you need to learn to innovate at every step. And business model innovation is one kind of method we use to innovate kind of use of new technologies, processes, unique ideas, strong partnerships, and so on. And digital transformation and business innovation go hand in hand with the company's overall development and market value. And a more kind of systemic approach to innovation can improve success rate, definitely. So strategies are promoting the business model canvas and a set of practices to help innovate your business model. And it's kind of see how the different areas of your business model can help you bring better values, and through partnerships, for instance, you can strengthen your value prop, even generate more revenue streams. And with the 5G and Edge, more IoT devices coming in, the partnership of the business model is an important area to focus on. Or how can we change the value proposition, what we offer to the customers? How can 5G edge computing kind of really innovate how we are providing our services? We've been discussing the AR technologies and how that can improve the user experiences. How can more real-time analysis and decision support make value for our customers' users? Like in the emergency case, it can be life-saving or avoid significantly damages. And if we look into the business model, it is to assess different sides of your business or new business, new ideas to provide cost savings, optimize services, new value streams through innovating your business model. And it's a great tool. We use it quite a lot in both our own business and with customers. It consists of kind of 5 different phases, and it starts with understanding. Before you go on to kind of designing and implementing a business model, we really need to understand the needs, the partners, potential partners, the customers, the technical opportunities, and so on. And kind of the young people today, they expect more kind of better user experience, more data coming up directly. Kind of latency is crucial to be able to provide the best services for the growing generation. And insights from 5G edge computing can really benefit your business model and bring new business in the years ahead. So it's kind of, you can find many examples of usages of 5G edge computing for smart cities, and several studies, reports has been made the last few years, and we have just visited a few aspects here today with the application of 5G edge computing for smart transportation and smart security, and there are unlimited applications within smart cities, from transportation and security through healthcare to governance and smart environmental protection. And the possibilities within, for instance, industrial manufacturing are significant and increasing with more and more IoT devices and applications. So the question is kind of back to every one of us. How can we exploit the 5G and edge computing in our businesses and within smart cities moving forward? Thank you. Anders, then it's time for some Q&As, I believe.
Yeah, thank you so much, Ingvar, Didrik. Yeah, thank you so much to all three of you. If you have any questions to the speakers, please post them in the chat, and we will take them a little bit later. I just had a question for all three of you, because also as an outsider, I think there are so many interesting opportunities with 5G and edge computing, but my question is more like, maybe you can all give your attempt to answer that question, but like, where do you see like short-term possibilities are most promising, and where do you see it like going in the more long-term? Because as I understand it, like the 5G edge computing infrastructure would be a huge investment that will take some years to build out. So where do we start? And especially if you're a company who is interested in going into this but doesn't really know sort of the technology roadmap and what is possible at what time. Do any of you, maybe I can start with Gianfranco?
Okay. I think that yes. Well, let's split maybe 5G with the edge computing. So it's like 5G nowadays. It's I think that maybe here it's more related to the what is implemented so far is mainly related to the just enhancing the data rate, so it's not changing so much so far. So in the future, from one side, we will overtake the current technology that are like narrowband IoT and other technology for providing IoT. The part that is more critical and then is connected to the MEC, to the edge computing, is the part about this application, ultra reliable and latency communication. And that is, I think that is maybe the other panelists they can contribute more and give more input. And that is the part, because you need to have use cases, you need to have a kind of devices that are already there. So that is the more critical part, and my just opinion that everything will be ready in when we will start talking about 6G. So in a decade we will have something that is mature, let's say. But I think that maybe in 5 years we will have the first actual working and the first. But that is my opinion.
Thanks, Gianfranco. Henry, do you have any comments coming from the network side? I think you're muted.
Yeah, it looks better this way. Well, we think about these issues on a daily basis when we make decisions on where to invest, actually. As yes, you pointed out, it is not exactly free to set up a national 5G network, and it will take some time. But where we see sort of business case emerging, first of all, if you look at cities and consumers, you can see anything to do with esports, gaming, things like that, where B2B to C companies into providing this sort of services are quite interesting. And it will then drive consumer behavior towards 5G subscriptions to the most whatever terminals, computers, and so on and so forth to make the experience even better than it is today. When we look at the B2B side, I think we see a lot of interest for the private 5G networks, and I think there's 2 or 3 quite simple reasons. First, if the mobile operator industry has done less than perfect job in providing coverage, naturally some of the customers are interested that can I get it if I pay for it myself? And this is a discussion that we saw primarily, say, 2-3 years ago. Today we see industrial campuses, heavy industries where you move heavy loads, high precision, high speed, harbors, metalworking industries, forest industries, things like that, where all sorts of autonomous whatever is in high demand. And I think the second user group is when you need to add the word smart or autonomous or AI driven to something. We do cases where we have machine vision driven analytics. There's the connected worker, which is an interactive thing, but connected normally to a very complex digital twin of something. Those are probably the first ones that come to my mind and tend to be typical discussions where we engage with companies today.
Thanks, Henry. Ingmar, what are your, like, maybe since you have a researcher and a mobile operator, like coming from the industry side, what are the questions you might think that are most pressing for your clients or for yourself in the rollout of 5G and edge computing?
Yes, Anders, in relation to what Henry discussed, we see the kind of the private 5G networks. They are, of course, crucial for us to be able to move on within kind of areas like these emergencies and so on. I think we will see quite a lot of services of course in the consumer market, but also in smart cities moving forward. We see that kind of because of expectations in the user crowds, we need to have more kind of gamification and so on put into the experience. We need to bring on AR, kind of this hybrid world, and I think we will see that quite soon, being definitely a part of our lives. But for kind of industry use, it's more the private slices. I think it's kind of the needs we see most, and yeah, from our clients.
Yeah.
Agree.
Yeah. I can see there was one question was addressed to Gianfranco, but maybe others also have some comments on it. Has there been any attempts to test your 5G architecture on flying drones? I don't think you're that far, Gianfranco, but maybe you can comment on it anyways.
I know that there were some tests about done on drones. They had some collaboration with the people from the University of Padua in Italy that were doing a lot of activity on drones. Actually, they were working even them in the intelligence part. And actually, it's curious because we are even kind of thinking about expand our test in 5G modality using also drones, because now we are planning to use only the small remote controlled cars, and maybe we can use some of the budget for buying drones and do something that is a little bit more complex, even more 3D, let's say. So that's kind of interesting.
Thank you. Henry or Ingvar Dilek, do you have any comments?
In general, I believe that we have seen and we see more and more examples where the 5G supports, let's say, the development of drones, probably mostly from the sort of splitting the chip type of thing, that you don't need to equip the drone with so heavy processing, battery consumption. Just the sensors is enough if it can be real-time connected via 5G network to the logic that is actually on the ground. I could see that becoming quite interesting in some applications, again, over private networks, for example, in large industrial sites. And why not cities? I think some companies have spoken for years about delivering stuff to people's homes with drones, and applying these technologies could at least increase the relative payload for any drone. But it probably is a few years out still on the sort of broad scale smart city application. But in industrial instances, I can see that coming faster.
Thanks. Ingvar Dilek?
Yes, definitely we see it. Definitely we see it coming faster, for sure. And when we started off with Yago, just kind of half a year, 1 year ago, we believed kind of that we would see most things with kind of or have most exposure on the land side, on the ground. But what we see now is that we really have most activity in the drone side, and we will have at least tests with cargo drones during the next year in the Stavanger area. And of course, we have some of the major players within kind of drone technology with Nordic Unmanned and KVS technology with inspection of power lines and so on in the area. So we will definitely see more and more of that coming, and kind of one of the things we have to work with is, of course, offloading weight from the drones so that they can carry more more weight, and then use other infrastructure to do the computational power and so on. So definitely we'll see that moving forward to kind of optimize the drones as well.
Thank you. Then I think we have just time for one more question to the three of you. So my question is actually, what do you like? How do you see 5G and edge computing sort of like? Will it be just as disruptive or a revolution like the internet was for really restructuring a lot of industries and sectors? Like, do you see the same happening here, and like what should companies? How should companies sort of get ready for 5G and edge computing? Don't know if somebody wants to provide an answer to that.
Well, I can try my hand, and I think there's sort of two sides to it. The examples I showed and the examples that we have talked about, they are, I think, a function of performance improvement, but within the same sort of paradigm. And some research says that of all the new economic value to be created by 2030, we could actually create 60 to 75% of it with the technologies that we have today. So only less than half actually needs the next generation technologies to be able to be realized. So I think that part of the evolution will be, as I said, learning how to integrate, learning how to scale, learning how to modularize, bring the price point lower, build out the networks, and that will create possibility to realize some of the use cases that we already know more efficiently on a broad basis. I would call that the evolution rather than the revolution. Then what I tried to say in my presentation, that then there's probably a layer when a number of other technologies come together, like the AR, VR, or the distributed ledger things that create Web 3.0, and that will be a revolution. That's the only thing I can say from all the materials that I have seen so far. So I think there's sort of probably two parallel tracks that we will see going forward.
Thank you. Gianfranco, do you have anything to add?
Well, I agree with Harry about all the situation that at the end it's 5G is just a technology where maybe the part that is more innovative is this application of both UR LLC, but at the end it's actually for using and creating use case and so on is something that it needs something beyond the technology itself. Okay, so it's something on top, and this path that we will have in the future will be more about this integration, this adding intelligence, and developing even a nice business model where everything is coming together, and we are giving new applications, new services, new utilities to the citizen.
Thanks. Ingvar?
Well,
it's very well put from Henry and Gianfranco, and but it's kind of will they kind of revolutionize? At least they will optimize and help us optimize a lot of experiences, and kind of from before we've had this phone, and we need to kind of build experiences that people expect, and that goes both for kind of B2C and B2B. We need to build experiences and applications that people would like to use, and then we really need the infrastructure to to be able to do that, and then 5G and with the combination of edge computing will really bring a new kind of opportunities to the marketplace, for sure.
Thanks, Ingvar Didrik. Yeah, so this is also like we can do a little advertisement to Henry that please invest more in the Forest Stavanger area, because we have a lot of interest and research here. So you can talk to some of your colleagues and make sure that we get the 5G network built out here. But I would like to say thank you to all three of you and to those who listened. We have a science talk in May. There we will talk about battery technology, so it's very closely aligned with this, but more on how can we produce batteries more environmentally friendly. But there will be an announcement about that science talk in a few days. But thank you so much to Henry and to Gianfranco and to Ingvar Didrik for the presentations and the debate. It sounds very interesting, and I hope we will see some interesting applications and new solutions coming out soon. So thank you very much.